We're going to see what researchers just found sitting under Hawaii. They explored gigantic volcanic eruptions that led to mass extinctions. And you'll see the Virginia Tech map of it is sitting under Hawaii in the Pacific Ocean. This is by phys.org, Virginia Tech University. Researchers explored gigantic volcanic eruptions that led to mass extinction. Extinction level events, in other words. And this map shows the Pacific LLSVP boundary. And the pink in the area shows Pacific Oceanic LIPs. Now, the paper published in Nature Communications by Virginia Tech researchers confirms a major feature in the formation of large igneous provinces, massive worldwide volcanic eruptions, and you can see on the map they're basically in the Ring of Fire, plus the area of where we have a lot of Mexican, Central America Mexican earthquakes. It's the Mexican volcanic range, horizontal there, and you'll see that. You'll see the pink Pacific areas. Now, they've confirmed a major feature in the formation of large igneous provinces, massive worldwide volcanic eruptions, that created incredibly high volumes of lava and, of course, triggered environmental catastrophes and mass extinctions from 170 to 90 million years ago. Heading the new research is Esteban Gazel, an assistant professor in the Department of Geosciences, part of the College of Science at Virginia Tech, and alumni Pilar Madrigal, who graduated in a doctoral degree in geology from Virginia Tech in 2016, and is now an assistant professor at the University of Costa Rica. Quote, "We confirmed an ongoing working hypothesis that in order to form these massive eruptions, there has to be an input from deep mantle upwellings, as well as interaction with a shallow structure like a mid-ocean ridge, to allow the outpourings of large volumes of lava," said Madrigal. She says, "Our work also suggests that the deep upwellings of hot mantle material forming these large igneous provinces occurred in pulses of 10 million to 20 million years," she said. This hint of cyclicity, it goes in cycles, in other words, is an interesting result suggesting that there may be deep mantle instabilities occurring every so often that we still don't fully understand, and that could potentially be related with core mantle interactions. The hypothesis had been shown only in numerical and dynamical models until Gazel and Madrigal independently evaluated the geodynamic evidence with geochemical and petrological models they produced to find robust correlations indicating that this interaction was key in forming large igneous provinces. Large igneous provinces, LIPs, are massive formations of igneous rock made of volcanic and intrusive materials, all formed from rapid production of magma. Large igneous provinces are scattered around the world in ocean basins bordering Siberia, Africa, India, and on the east coasts of North and South America. In this study, Gazel and Madrigal focused their attention on the Pacific Ocean locations. Quote, "The generation of these igneous provinces correlates with some of the most devastating events in our planet's history," Gazel said, who spearheaded the study. "The geological record of these events contain crucial information to understand the inner dynamics of Earth's mantle, but also, every time they happen, they completely changed life on the planet." Amazing. Gazel and Madrigal studied the geochemical composition and timing of the large igneous provinces that occurred in the Pacific Plate during the Mesozoic period in the time span of between 170 and 90 million years ago. They collected samples of underwater lava flows now exposed along the Pacific coast of Costa Rica. These lavas were formed in the Pacific and were brought to the surface by tectonic processes, said Gazelle. Quote, the field work was very exciting because one could see these underwater formations that are now exposed on the surface, Gazelle said, adding that their collection efforts included boat trips, swimming to outcrops, and hiking along the coast. And Gazelle knew the area well. He spent summers in the Nicoya Peninsula of Costa Rica. He said, these rocks and I go back a long way. I used to spend the summers playing and getting in trouble on those pillow basalts during my childhood, end quote. In collaboration with Kenneth Flores, assistant professor at Brooklyn College in New York, the team produced a series of kinematic models to calculate the Pacific's paleotectonic configuration during the Cretaceous period. The study also included isotopic and age-dating data collected in collaboration with researchers Michael Bizimis and Brian Jika from the University of South Carolina and the Weizark Geochronology Laboratory at the University of Wisconsin-Madison, respectively. The study findings suggest a relationship between eruption of these provinces and the location of paleo-mid-ocean ridges, where normal oceanic crust forms in a steady-state fashion, and the position of the edge of the Pacific Large Low-Shear Velocity Province, a thermochemical anomaly roughly 1,860 miles wide between eastern Australia and the west coast of South America, located deep in the earth at the Mantle core boundary. And as you can see from the map, it also encompasses Hawaii. This new discovery suggests interaction between deep, hot mantle upwelling and mid-ocean ridge, enabling the formation of large igneous provinces. Gazelle added, this is an important breakthrough as we can better explain why these events were so big. To put things into perspective, the pulse that happened 120 million years ago that formed the Ontang, Java, Manihiki, and Hukurangi large igneous provinces covered an area equivalent to about 40% of the continental United States in a very short time. Most of these magmatic provinces formed at the same time as an event known as the Cretaceous Normal Superchron, roughly 120 to 80 million years ago, when for millions of years the Earth's core did not change its polarity, which was most likely caused by fluctuations of core mantle heat flux, Gazelle said. He said there were many other extinction level events throughout history, such as the one nearly 300 million years ago that almost wiped out all life on our planet, from the eruption of the Siberian Traps, another large igneous province. He said understanding these processes is not only important to decode the deep puzzles of Earth, but also to better understand the fragility and resilience of life on our planet. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.